Let's look at example number 26 from this section. It says, porphyrin is a pigment in blood protoplasm and other body fluids that is significant in body energy and storage. Let X be a random variable that represents the number of milligrams of porphyrin per deciliter of blood. In healthy adults, X is approximately normally distributed, so that's our key here, with a mean of mu equal to 38 and standard deviation sigma equals 12. So part A asks us, what is the probability that X is less than, so we use less than, 60. Okay, for the normal distribution, we can either convert it to a Z, standard normal random variable first, and then use the table, or we can go directly and use the normal CDF. This example, I'm going to be using the calculator. So I'm going to draw my picture to know what I'm looking for. My middle's 38, but 60 is over here. Correct? Because the mu is 38. So I put my mean here so I know where to draw my line for what I'm looking for. So less than 60 is the whole area to the left. Okay? When I do normal CDF on my calculator, remember we always put lower limit first. Well, when we have less than, this can go on to negative infinity here. So what we use is a very large negative number. Some students will even use negative 10,000, but oftentimes if you're not sure how small to go, we can say negative 1 times 10 to the 99. The way we do that on the calculator is we say negative 1 E99. So it really means negative 1 with 99 zeros. So that's a big negative number. So we assure that any rounding is minimized. Our upper limit, so our lower limit is the left side of the shaded area. The upper limit is the right side of your shaded area. And that's why it helps to shade first. So we do comma 60, and then we do mu sigma. So 38, comma 12. So we put that into our calculator. We go second vars, like we did before. Turn it on. Second vars. We go to normal CDF. Now some of your calculators may ask you lower and upper. So the way we put negative 1 E99, make sure you use this negative button, not the minus sign. We need to use this negative. So we do negative 1. And then where we get that times 10E is above the comma key. So we do second, comma, and it will put an E in. 99. And we do comma, 60, comma, 38, comma, 12. Make sense? So I get 0.9, and I usually take it out 4 decimal places, 0.9666. Okay? Okay, part B then asks us probability that X is greater than 16. So again, let's draw our picture. Our mu is 38, so that's our center. So is 16 to the right or the left? It's to the left, somewhere over here. So I'll put 16. Greater than means I'm shading this whole area to the right. Again, we could convert this to Z using X minus mu over sigma, convert the 16, use the table, but we're going to use the calculator here. So we do normal CDF. Okay, our lower limit, when we look at the shaded, is the left-hand side, so this time our lower limit is 16. Make sense? Again, our upper limit is the right-hand side. Again, this goes on forever. Okay, but it's going in the positive direction this time. So we do positive 1E. 99. Make sense? Mu sigma. So we do our calculator again. We do second distribution, normal CDF, 16, comma, 1 E. Remember E is above the common key. 99, comma, 38, comma, 12. again, we get 0.96. Whoops. 0.9666. So had we converted these to z-scores, we would see that 60 and 16 are probably the same z-score. One's positive, one's negative. Okay? It looks like they're positive, right? So if we would have converted, it'd be positive 2 and negative 2. Okay, let's do part C. The x is between 16 and 60. So had we done our z-scores here, we could change this into the z-scores, but let's do our normal CDF. Okay, let's draw our picture. 38's in the middle, 16 is over here, 60 is over here. We want the area between them, right? So now with the normal CDF, our lower bound is 16, our upper bound is 60, mu, and sigma. So normal CDF, 16, comma, 60, comma, 38, comma, 12. 0.9332. Okay?